China is building the world's largest dam in Tibet, in the upper stream of the Brahmaputra.
China has just approved what will become the world's largest hydroelectric project, and what I'm about to tell you will change everything you thought you knew about mega infrastructure. Deep in Tibet's Zangpo Canyon, the world's deepest gorge, construction is about to begin on a dam that will generate 3 times more electricity than the legendary Three Gorges Dam. Think about that for a moment. The Three Gorges Dam was already a marvel of engineering. Now multiply its power output by 3. That's what we're looking at here. This new mega dam will generate an estimated 60 gigawatts of electricity annually, equivalent to nearly 300 billion kilowatt-hours, more than 3 times the output of China's iconic Three Gorges Dam, which produces 88.2 billion kilowatt-hours annually, making it the most powerful hydroelectric dam ever built. Let's talk numbers. This beast will cost over 1 trillion yuan, that's $137 billion. That's more than the GDP of many countries, poured into a single project that will reshape not just Tibet's landscape but potentially the future of Asia's water supply. The dam will be built on the Zangpo River, which originates in Tibet and later flows into India and Bangladesh as the Brahmaputra River. It's one of Asia's mightiest rivers, carrying enormous volumes of water through some of the most dramatic landscapes on Earth. What makes this location unique is that the river cuts through the world's deepest canyon, with an average depth of about 2,268 meters, 7,440 feet. At its deepest point, it reaches up to 6,009 meters, 19,714 feet. To put that in perspective, that's more than twice the depth of the Grand Canyon. This natural gradient provides an unparalleled opportunity for harnessing hydropower. The engineering challenges here are unprecedented. Construction teams will be working at extreme altitudes in one of the world's most seismically active regions. They'll need to manage enormous water pressures while building in a canyon that sees some of mainland China's heaviest rainfall. Every aspect of this project pushes the boundaries of what we previously thought possible in dam construction. Construction teams will need to drill 4 to 6 tunnels, each stretching 12.4 miles, 20 kilometers, through solid mountain rock. These tunnels will redirect half the river's flow, about 7,629 cubic feet, 2,000 cubic meters of water every second. The teams will deal with extreme pressure differentials while working in a canyon where water flow varies dramatically between seasons due to snowmelt and monsoon rains. The geology adds another layer of complexity. The area contains 43 major landslide zones. Just one of these, the Matur landslide, holds 25.6 million cubic meters of unstable earth. The dam must be engineered to withstand not just these geological hazards but also significant seismic activity, as it's being built in one of the world's most earthquake-prone regions. Here, 9 out of 10 mountain cliffs have historically experienced collapse. The construction process itself requires unprecedented infrastructure. Teams are building high-quality mountain roads, establishing support facilities, and installing sophisticated seismic monitoring systems. They are also implementing cutting-edge water quality control measures to protect the ecosystem. To give you an idea of the scale, this single structure will produce more electricity than many countries' entire power grids. The engineering team must account for water pressures never before managed in dam construction while building in a location where the river makes a dramatic U-turn around Namche Bawa mountain. The construction methods being developed here will likely revolutionize how we approach mega infrastructure projects in extreme environments. Every aspect of this dam's design must account for conditions that no other dam has ever faced, from the extreme altitude to the unprecedented water pressures to the complex geological formations. So why is China pouring so much money into this? Well, there are 2 main reasons. First, China is on a mission to transition to renewable energy. As one of the world's largest carbon emitters, it has pledged to reach carbon neutrality by 2060. Projects like this are key to reducing its reliance on coal and other fossil fuels. Second, there's an economic angle. Hydropower projects like this one aren't just about electricity, they're also about jobs and long-term economic growth. By investing in infrastructure like this dam, China aims to boost its economy while securing its energy future. But let me ask you this: at what cost? While these numbers are impressive, they don't tell the whole story. The technical achievements are significant, but they come with major environmental and social costs. Let's talk about the environmental impacts first. Tibet's high-altitude plateau is one of the most fragile ecosystems on Earth. Building such a massive dam could disrupt local biodiversity, submerge vast areas of vegetation, and even contribute to greenhouse gas emissions like methane. When vegetation decomposes underwater, it releases methane, a greenhouse gas far more potent than carbon dioxide. The region is a biodiversity hotspot, home to unique species that have evolved to thrive in this high-altitude environment. Their habitats will be forever altered. Then there's the human cost. Entire communities face displacement, including ancient Tibetan settlements that have called this region home for generations. We're talking about the potential displacement of up to 1.2 million people near various dam project sites. Centuries-old monasteries and sacred sites will disappear beneath the reservoir waters. These aren't just buildings, they are the physical embodiments of Tibetan cultural identity and history. Moreover, the sheer weight of water stored in such a large reservoir increases the risk of landslides and earthquakes, a concern that cannot be ignored in a seismically active region. China presents this project as a crucial step toward achieving its carbon neutrality goals by 2060. On paper, hydroelectric power is clean energy, but the reality is more nuanced. Large hydroelectric projects can significantly impact local weather patterns, alter ecosystems, and change river dynamics in ways that affect millions of people downstream. The geopolitical implications are equally complex. India and Bangladesh watch this development with growing concern. The Yalong-Zangpo River doesn't stop in Tibet, it flows downstream into India and Bangladesh as the Brahmaputra River, a lifeline for millions who depend on it for agriculture, drinking water, and flood management. Reduced water flow or southern releases could severely impact agriculture-dependent regions in northeastern India and Bangladesh. These fears are especially pronounced given ongoing border tensions between China and India near Arunachal Pradesh, a region through which the Brahmaputra flows. The dam gives China unprecedented control over water flow to these downstream nations, adding another layer of complexity to already tense regional relations. Imagine having your hand on the tap that controls the water supply for hundreds of millions of people. That's essentially what this dam represents. Despite tight controls on public dissent, local opposition has emerged. Recent protests against similar dam projects in Tibet, like the Kamtok Dam, demonstrate the depth of local concern. These rare public displays of resistance have faced swift crackdowns, with hundreds of arrests reported. From a strategic perspective, China's aggressive dam-building spree on transboundary rivers originating in Tibet is seen by some as an attempt to assert dominance over regional water resources. As climate change makes water increasingly scarce in South Asia, such control could become a flashpoint for conflict. The Chinese government has implemented various environmental protection measures, including ecological conservation programs and wildlife protection initiatives. But critics argue these measures are insufficient given the project's massive scale and potential impact. Looking at the economic implications, we're seeing the creation of thousands of jobs and the development of new technologies. The regional economy will undergo a transformation as infrastructure develops to support the project. The international community's reaction has been mixed. Environmental groups warn of irreversible damage to Tibet's ecosystem. Engineering communities worldwide watch with technical interest, and downstream nations express deep concern about their water security. As construction begins, several key questions remain unanswered. How will the dam affect the region's seismic stability? What will be the long-term environmental impact? Can downstream nations secure guarantees about water flow? How will displaced communities preserve their cultural heritage? Opinions about this mega dam are deeply divided. On one hand, proponents argue that it represents a monumental step forward for renewable energy production. With its unprecedented scale, it could help China achieve its ambitious goal of reaching carbon neutrality by 2060 while reducing reliance on polluting coal-fired power plants. On the other hand, critics highlight serious environmental risks and social injustices associated with such mega projects. Environmentalists warn that Tibet's unique ecosystem could suffer irreversible damage, while human rights advocates emphasize that displaced Tibetan communities are losing their homes and cultural heritage without adequate compensation or consultation. So here's my question for you: can China balance its development goals with environmental sustainability and regional cooperation? Or will this project become another example of progress at too high a cost? Let me know what you think about this mega dam project in the comments below. I'd love to hear your thoughts.